In this problem, we're going to find all relative extrema and points of inflection. So we've got f of x is equal to negative x to the third plus 3x. Now, first thing we'll work on is the relative extrema. We need our first derivative. So the derivative of this gives us negative 3x squared plus 3. Now I'm going to do the relative extrema here, and then I'm going to do the points of inflection over here. So I'm going to go ahead and find my second derivative while I'm at it. So the derivative of negative 3x squared is negative 6x, and 3 drops away. Okay, back to our first derivative. This is the first derivative test. We want to find our critical values. So we're going to set that equal to 0. So negative 3x squared plus 3 equal to 0. Take the negative 3x squared to the right side and becomes a positive 3x squared. Divide both sides by 3. 3 divided by 3 is 1. 3 divided by 3 here, the 3's cancel and gives us x squared. Square root property. If you got something squared equal to the other side, you drop your squared and you put a plus or minus square root around the other side, which then gives us x is equal to plus or minus 1. Those are our critical values. And we want to build a table of intervals. Clear over here is negative infinity. Clear over here is positive infinity. We want to choose test cases, something between negative infinity and negative 1, like negative 2. Something between negative 1 and 1, which is 0. And something greater than 1, like 2. Now we want to plug those into our derivative, which is right here. You could use calculator to do this. I'll just talk it through. All we care about is a sign. If I put negative 2 in here, negative 2 squared is 4, times negative 3 is negative 12, plus 3 is negative, so this is decreasing. If I put 0 in there, 0 squared is 0, times negative 3 is 0, plus 3 is positive, so it's increasing. And if I put 2 in for x, 2 squared is 4, times negative 3 is negative 12, plus 3 is negative, so it's decreasing. So, it's not asking us for increasing and decreasing. It says find all relative extrema. You have mins and maxes when it changes. Here's decreasing and changes to increasing, so this is going to be a min. And this is increasing and changes to decreasing, so this is going to be a max. So we're going to have a min at negative 1 comma something, and we'll have a max at 1 comma something. Now I'm going to plug my original function in my calculator, even though this is pretty straightforward. So come over, press y equals, clear, negative x to the third. Press your right arrow key if you go on the New Year TI-4 to get out of exponent mode, plus 3x. And I want to make sure my table set up correctly, so I do second window to go into table setup. And we want independent to say ask. If it doesn't say ask, down arrow to that line, right arrow, put your flashing cursor on the ask and press enter one time. Now if we go to second graph, I'll press delete a couple times, even though those are actually our numbers, I believe. We're going to plug negative 1 and 1 back into our original function to get our y parts. So we'll do negative 1, enter, 1, enter. So negative 1 gives us negative 2, and positive 1 gives us a positive 2. And those would be our relative extrema. Okay, now to our second derivative. We want to set it equal to 0 and solve. Well, if we divide both sides by negative 6, we get x is equal to 0. That's our critical value. And we want to build a table of intervals based upon that. Here's negative infinity. Here's positive infinity. I want to choose test cases. Choose something between negative infinity and 0, like negative 1. Choose something between 0 and infinity, like positive 1. Now, we want to plug this into our second derivative, see what our signs are. So if I put negative 1 in for x, I get negative 6 times negative 1, which gives us positive, which means it's concave up. If I put 1 in there, Negative 6 times 1 is negative, so it means concave down. Now our POI is where the concavity changes, assuming the point exists. This changes from concave up to concave down, so that's our POI. So POI is going to be 0, comma something. And actually that one's pretty easy. If I put 0 in for my x in my original problem, you get 0. So our POI is 0, 0. So those would be our answers. Now, you notice I didn't use second derivative test. I don't think it's that hard to create this table after you find your critical values. So, especially if you got a calculator doing a lot of the basic algebra there for you. Anyway, those are answers.